Hello everyone, today we're looking at problem number 2966, which is divide an array into arrays of max difference. So for this we are given an integer array nums whose size is a multiple of 3, and we're also given another integer input k. So we have to divide this input array called nums into n by 3 arrays such that the difference between any two elements um, in the child array is less than or equal to k. So what we have been given is an unordered integer array like this: 1, 3, 4, 8, 7, 9, 3, 5, 1. And if you see, this is a multiple of 3, so we need to create 3 new arrays and return the response as a 2D array. And what we want in this child array is that the difference between any two should be lesser than or equal to k. K for this particular example is 2. Okay, so 4 minus 1 is 3, so that does not satisfy this condition. 3 minus 1 is 2, that does satisfy the condition. And so one thing to observe here is that if we want all the elements of an array to follow this condition, this particular condition has to be followed by two very specific elements, which is the max and the min. Okay, if the max and the min are if the difference between the max and the min is lesser than or equal to k, then all elements between max and min will have a difference between that. So if you see on a number line, if this is the min and this is the max, and if this difference is acceptable to us, then either this to this distance or this to this distance or any intermediate point, this to this distance, is anyway going to be lesser than that, because we are playing in this range. So the difference of any other two elements within the list is obviously going to be acceptable. So the first thing that we want to optimize is make sure our max and min of an array follows that. Now we are given an unordered list, and the size of this list is 10 power 5. Now when it comes to filling these, let's say if we were filling it using a brute force way, we will probably add a minimum here, and then we will need to scan through this whole array to find the numbers that are closest to this number that we might have selected. And so you can imagine that you will have to scan this array multiple times for different settings. Let's say you will search for other minimum value, which is if you have taken minimum as a 2, but in this example the minimum is 1, you look for other occurrences of 1, then you do minimum plus 1, you look for 2, and you do this till you satisfy the 3 element condition on this child array, and then you move to the next child array where you have to find the minimum. Let's say this is at 0th index. Now minimum based on the elements that are now left. So this is going to be definitely not so straightforward. I can very clearly say that this would definitely be order of n square, because if you say this is n by 3 uh, uh, sets, and then for everything I am scanning through all of the elements, let's say again, so this becomes the time complexity of some algorithm like that. So we will have to be a little smarter. We can be greedy here. So what if I take the nums and convert it to nums sorted? Okay, and so let's do that for this array. this would become 1 1 double 3 4 single 5. There's no 6, there's 7 8 and 9. Let's see if I have got this correctly. Yes, I've got all the three sets. And so now this is basically the smallest min max set that I can possibly have. So this is the max for this set and this is the min for this set. Okay, and this is the smallest min max set, and because this is the smallest, this is more likely to follow our difference less than k condition. Okay, and so in case it does not, then we just have to return this. If it does, then okay, we keep progressing and continue. Okay, so now let's quickly review the pseudocode for this, and that's all that is there to this problem. So the trick to this problem was thinking about this as a greedy problem, and then taking jumps of 3, and then while you take the jumps of 3, you take the difference between the min and max of this set, and then you check if it matches the condition or not. Okay, so if I have to now write the pseudocode, let's say n is equals to len of nums, and let's have nums sorted, which is equals to sorting the input, and then let's say my results is equal to an empty set. Okay, so for index in range 0 to n with jumps of 3, okay, what we check is if nums sorted index plus 2 minus nums sorted index, if it is greater than k, then we just return empty set because it violates this condition, and this difference is greater than k for that instant. And if it is not, then we just append this set. Okay, so we just append because we want the 2D output, right? We want the output to look like this, the 2D. So let's do that. We say nums sorted index to index plus 3, taking into account the last index which will not get covered, and then return result. Results. That's about it. Yeah, so that's about it for this problem. After sorting, so the time complexity of this is the sorting complexity plus the scanning complexity, which becomes log of n log n plus n, and so the overall time complexity is n log n. That's about it for this problem. Thank you. See you with the next problem.